What's good, everybody? RFG is here today to go over a particular subject known as genetic splicing once again. I want to let everyone know that this past week or so, I learned something new. I basically learned that just because an animal is in the wild, okay, does not mean that it was not genetically spliced, okay? Just because an animal is in the wild in nature does not mean that it's not genetically spliced, okay? Because, there's information that I stumbled upon in the past couple of weeks, very profound information, okay? And it was basically proving that there are certain wild animals that came here as a result of genetic splicing, okay? So in this video, I'm not going to be touching on any mammals or reptiles or birds or even fish for that matter. I'm going to save that for a different lecture. So this video is going to be strictly on insects and arachnids, and I'm going to be touching on the insects and the arachnid that I found proof of that it's genetically spliced, okay? There's three creatures that I stumbled upon that, have a lot of proof and a lot of similarities to other insects. And there's basically a lot of evidence that points to them being genetically spliced, okay? As we know, our ancestors had a splicing program that went on to domesticate certain animals thousands and thousands of years ago. While they were doing that, this goes for all species on this earth, ladies and gentlemen. They were splicing insect species as well, okay? And I'm gonna prove that in this lecture, so just stay tuned and listen very carefully. Okay, first off, we have this praying mantis creature. Okay, so without further ado, I'm gonna get into what this praying mantis creature is all about and why it was held in such high regard to our ancestors. Okay, so let's just look at this praying mantis creature. We have these mandible-like serrated arms. These mandible-like serrated arms that are perfect for it to capture its prey and for it to eat it. Okay? This thing is this insect is a carnivore. It's carnivorous. It eats other animals. It eats other life forms. Okay, this creature has been caught eating lizards, eating small rodents, okay, as well as other insects. This is a very intelligent insect. Okay, very intelligent. Very long body, very long arms and legs, very long abdomen, the ability to fly, and it has the ability to change colors with its environment. Okay? So, I know you would ask me, what is this praying mantis mixed with? If it's a result of genetic splicing, what has it been spliced with? I want to let you guys know that before I go any further, that all insects on this planet at one point were crustaceans in the ocean. Let me repeat. All insects and all arachnids on this planet, 100% of them, their DNA goes back to the ocean because they are directly related to crustaceans. Crustaceans that dwell in the ocean. Okay? For everyone who doesn't know what the crustaceans are, okay, the crustaceans would be the crab species and the lobster species. Okay? Those are your two crustaceans. All insects and arachnids on the planet go back to the crustaceans. You know why? What do the insects and the crustaceans have in common? The crustaceans have an exoskeleton. The insects and the arachnids have an exoskeleton. That means their skeleton is on the outside of their body, and the soft parts of their body and their organs are on the inside. That is the opposite of mammals, okay, and birds and reptiles. That's the opposite, okay? Crustaceans, insects, and arachnids have very hard exoskeletons. Their skeletons are on the outside of their body, okay? So once again, like I said, every single insect species ties back to a crustacean that comes from the water. All life forms on this planet come from the water, okay? The insects are no different. So let's go back to this praying mantis here. Okay, so what do you think? What do I think a praying mantis was spliced with? Well, I'm about to blow you guys away. The praying mantis comes from a crustacean. The praying mantis comes from a crustacean. Okay, this is their base species. The praying mantis comes from a crustacean known as the mantis shrimp. Known as the mantis shrimp. When you look at the mantis shrimp, it is an aquatic creature that has the same exact arms as the mantis, as the praying mantis. The mantis shrimp. Same exact arms as the praying mantis. Same long antenna. Same long antenna coming out of the head. Same long abdomen. Same long abdomen. Okay? It has the fin-like structure at the bottom of the abdomen to help it swim. And it has very small legs, unlike the mantis. But I'm getting ready to touch on that really quick. Okay? So the base species of the praying mantis is the mantis shrimp. You get the long antenna. You get the arms. You see what I'm saying? The serrated sharp arms to capture its prey from the mantis shrimp. And you get the long abdomen from the mantis shrimp. Okay? The base species of the praying mantis. Okay, look at those arms. Look at those arms. Look at those arms. Base species of the praying mantis is the mantis shrimp. Look at those arms. Look at that abdomen. Okay, look at those long antenna. Look at the long antenna coming out of the praying mantis. So I just showed you most of the DNA that comes from this praying mantis comes from the mantis shrimp. Let me show you the other insects that this insect was spliced with. Okay? Not only was it spliced with the mantis shrimp, the praying mantis was spliced with the DNA of a stick bug. Okay? Look up the stick insect. Okay, the stick bug. Ladies and gentlemen, when you research a stick bug has very long legs, very long limbs, very long body, very long legs. Okay? And it's also capable of changing its skin color, changing the color of its exoskeleton to match the color of its environment. Let me repeat. The stick bug has the ability to match the color of its environment. Okay? Somewhat like a chameleon. The praying mantis has the same capability, ladies and gentlemen. It has the ability to match the color of its environment. So it got these very long legs. See, it didn't get these long legs from the mantis shrimp. Look at the mantis shrimp's legs. Very small and skinny. Okay? So where did the praying mantis get these very long legs and very long, lanky body structure from? It got it from the stick bug, from the stick insect. Okay? Long legs, long limbs, and the ability to change colors with its environment. Okay? The chameleon effect. Okay? So this is how the praying mantis is able to do that. It has stick bug DNA. It has mostly mantis shrimp DNA. And this is the icing on the cake, ladies and gentlemen. The praying mantis is a very intelligent species with a highly developed brain for an insect, also with very large eyes and perfect eyesight, okay, and the ability to fly. So where did it get this superior intelligence from, this head from, and this eyesight? Okay, where did it get the intelligence from? Where did it get the ability to fly from? Ladies and gentlemen, the praying mantis gets that from none other than the hornet, species, okay? Look at the large compound eye. The praying mantis has a large compound eye, just like this hornet. Very long antennas, okay? Just like this hornet. This hornet has thick antennas. The mantis shrimp has very long, skinny antennas, okay? This praying mantis has very long antennas, okay? But they don't go out in a direct vertical 0-degree motion like the mantis shrimp. You see, they spread out separate from each other, okay? Just like the hornet. Okay? So it gets the large compound eye and the brain and the head and the mandible structure, the jaws and the mandible structure from the hornet. Okay? Was spliced into this DNA to create the praying mantis. Okay? Very, very profound information. This is why the praying mantis was held in such high regard, and our ancestors paid so much respect and homage to the praying mantis species, because our ancestors, when they were trying to create this creature, they were trying to create the perfect predator. The perfect predator. Okay? Superior intelligence, the intelligence of the hornet, the eyesight of the hornet, the mandibles of the hornet, the arms, the serrated arms of the mantis shrimp, okay? The ability to change colors with its environment, just like the stick bug, the long, lanky body, just like the stick bug, okay? And the abdomen of the mantis shrimp, and the ability to fly, okay? Do your research. The mantises have the ability to fly, just like the hornet. Okay, so it has the head and the wings of the hornet, body structure of the mantis shrimp, arms of the mantis shrimp, okay, arms of the mantis shrimp, and the legs, the long lanky legs that comes directly from the stick bug, as well as the ability to match the color of its environment, just like the stick bug. Okay? Those are the three animals that this mantis was most obviously spliced with, ladies and gentlemen. Okay, the praying mantis, you know what I'm saying, was not here for more than a couple of tens of thousands of years. Okay, so that basically sums up the information regarding that creature. Okay, so my next insect I'm gonna be touching on, as far as genetic splicing, is gonna be this hornet creature, or this wasp. Okay, the hornet, the wasp, and the yellow jacket were all a result of genetic splicing. Once again, the hornet, the yellow jacket, and the wasp were all a result of genetic splicing. Okay? And this is pretty obvious, okay? This is not rocket science at all. Okay? We're going to look at this creature known as the bee. Known as the honeybee, the bee. Okay? Look at the thickness of its legs. Look at the thickness of its body and its abdomen. Look at all the fur. Look at all that, all those forms of hair on its body. Okay? Then compare that to the wasp. Okay, compare that to the wasp, the yellow jacket, and the hornet. They're not going to have all that hair, ladies and gentlemen. Their bodies are going to be much skinnier, ladies and gentlemen. The wasp, yellow jacket, and hornet's legs are going to be much longer, skinnier, and lankier, ladies and gentlemen. Their head is going to be much more sleek. Where do the wasps, yellow jackets, and the hornets get this body structure from? Ladies and gentlemen, they get it from the ant. They get it from the ant. Okay? The ant on this planet goes back millions and millions and millions of years. As far as I'm concerned, the ant is not a result of genetic splicing. Okay, the ant goes back damn near billions of years. Okay? Just like the bee. Just like the bee. Okay, but as far as I'm concerned, these wasps, these yellow jackets, and these hornets are a result of genetic splicing, okay, that is crossed with ant DNA, and bee DNA. Okay, so the wasps, yellow jackets, and hornets keep the color of the bee. They, you know what I'm saying, they keep the basic body structure of the bee, but the body structure, you see, fits the shape and the elongated form of the ant. Okay? This is what happens when you mix the ant. Oh yeah, they also get the long, lanky legs from the ant. So when you mix the ant DNA with the bee DNA, of course, you get, you know, the wasp, yellow jacket, or the hornet. Okay, very obvious. Very obvious. Okay? This is also what makes these wasps, these hornets, and these yellow jackets very, very aggressive. Very aggressive. Okay, and very violent. There's certain species of hornets and wasps that have been known to kill fully grown tarantulas and lay eggs in fully grown tarantulas. Do your research, okay? They get that aggressiveness from the ants, okay? Flat out. Flat out, ladies and gentlemen. So I'm going to go and move over to my next genetically spliced insect, or arachnid, should I say. This is going to be a genetically spliced arachnid. And this genetically spliced arachnid is known as none other than the camel spider. Go look at the camel spider, ladies and gentlemen. The camel spider lives mostly in the Middle Eastern part of the world. Okay, countries like Iraq, Iran, Afghanistan, Pakistan, Saudi Arabia, you know, Northern Africa, that area of the planet. Okay, this is the camel spider. Highly aggressive, highly venomous. There were people telling me about this creature when I was a teenager, and I was thinking that they were bullshitting. Like, I was like, no way. They said that this animal was capable of killing dogs, cats, okay, and large rodents. Okay, small dogs and cats and large rodents. This animal would kill and eat. And when this animal would bite humans, okay, when this animal would bite humans, it would hit them with a very powerful toxic venom. Very powerful. Okay, look what this camel spider did to this rodent. Okay, its venom basically dissolved and disintegrated the rodent's flesh. Okay, very powerful venom. Very dangerous animal, very dangerous creature. Okay, look at the jaws of this creature. Look at the jaws of the camel spider. Okay, I'm gonna show you the full body of this camel spider. Okay, right here, that's the full body of the camel spider. Show you from a different angle right there. Okay, the camel spider was spliced with two different animals, and it's very obvious what this animal was spliced with. Okay, we're just gonna get a close-up on the jaws of this animal. Okay, look at the jaws and the teeth of this camel spider. Okay, the camel spider has 8 legs. Okay, so it's an arachnid. It's an arachnid, just like a scorpion and a tarantula. So when we look at the jaws and the teeth of this camel spider, we will notice that the jaws and teeth of this camel spider are a direct resemblance of scorpion pincers, ladies and gentlemen. So the camel spider gets its color, its abdomen, and its jaws from the scorpion, ladies and gentlemen. And it gets its long 8 legs, okay? And it's, it's a large piece of its abdomen from the largest tarantula in the world, okay? The largest tarantula in the world is the Goliath bird-eating, tarantula, okay? This looks well over about 2 feet, a good 2 feet, 1.5 to 2 feet in diameter, okay? Also in circumference or perimeter of, the length of its limbs, of its legs, okay? So you cross a Goliath bird-eating tarantula with most species or any species of this scorpion, okay? And you're gonna come out with this camel spider, ladies and gentlemen, okay? You're gonna come out with this camel spider who has the jaws and the teeth and the mandibles, okay, that are a scorpion's hands, that are basically come from a scorpion's pincers, a scorpion's hands. But that is the teeth of this camel spider, okay? Directly linked, directly related, okay? They share a piece of DNA, ladies and gentlemen, okay? And then when you talk about the long, lengthy legs, they come directly from the tarantula. Okay, so the camel spider is the cross between the tarantula and the scorpion. The only thing it didn't get from the scorpion is the long ass stinger. Okay? But I think the venom from the scorpion stinger was placed in its jaws, because if you do your research, these camel spiders are very fast, very quick, okay? They can jump. They have the ability to jump. And they're known for killing small dogs, small cats, large rodents, and eating them, ladies and gentlemen, okay? If you don't believe me, just go look up the camel spider and look up camel spider attacks. Camel spider attacks. Very aggressive creatures. Very aggressive. Okay? They get that. See, scorpions are somewhat more on the quiet side. They really don't attack unless you've harmed them. So I think this camel spider got most of that aggressiveness from tarantulas. Okay? Because if you do your research, a lot of these species of tarantulas are known for eating creatures much larger than them. Okay? Okay, these tarantulas are known for eating certain birds and very, very large rodents. Okay, so I think that's where the camel spider got most of its aggressiveness from, was from the tarantula. Okay, so that basically sums up the information I had regarding the spliced animal, the spliced arachnid known as the camel spider. Okay, this this next, well, no, that was basically, yeah, that was the last spliced animal I had on this subject today. I just wanted to tell you that the tarantula and the scorpion, okay, they are very ancient. They are very ancient. I did not find any information that led me to believe that these tarantula species or these scorpion species were a result of genetic splicing. Okay, when I did my research, my research led me to information that told me that the tarantula and the scorpion species is very old and was originally aquatic. Okay, this species originally came from the water, the ocean. Okay, same thing for the scorpion. Same thing for the scorpion. Not a result of genetic splicing. They come directly from the ocean, and they, at one point in this world, the scorpion and the tarantula were aquatic. Okay, because there was no other animal that I could think of off the top of my head or through research that shared this same stinger. Okay, so when I did my research, I found that at one time the scorpion was aquatic. Okay, the scorpion was aquatic, and it was known as the Jacalopterus. The Jacalopterus. Okay, then you have the Megalograptus, and then you have the Eurypterus. Okay, so the Eurypterus, the Megalograptus, and the Jacalopterus, those three species had stingers. Okay, okay, with venom. And all three of them were aquatic. Okay, this is when the scorpions were in water. Like I said, the insects at one time were crustaceans. So these sea scorpions were crustaceans. Okay, look at these images. Look, that's exactly what they look like, ladies and gentlemen. This right here is photoshopped because this creature doesn't exist anymore. They can only find fossils of this creature at this time. Okay, sea scorpions did exist. Okay, all the insects, all the arachnids that you see originated from a species that came from the water. Okay, plain and simple. Okay, sea scorpion. A scorpion is an original animal that comes directly from the water, directly from the sea, from the ocean. Okay. Also, the tarantula comes from the ocean as well. Okay, here's the tarantula, and here is a sea tarantula. Okay, go put this in on the internet. Ladies and gentlemen, this is why that the government kept this information secret. They did not want us to touch on this genetic splicing topic. Okay, they did not want us to touch on this information at all. They wanted us to buy into their evolution bull crap. Okay, that takes the power and the energy away from our ancestors who were the creators of this genetic splicing program that took place on Earth. The genetic splicing information goes directly against evolutionism. You see what I'm saying? This is why they never told us this about these creatures that really exist, like sea scorpions and sea tarantulas. Okay, you can put this in on the Google, whatever search engine you want, and it's gonna come up. This is a crustacean in the ocean known as a sea tarantula. Okay, they also have sea spiders. If you put in sea spiders, this is what's gonna come up right on the screen. Okay, I told everyone all animals, all life forms start out in the ocean, plain and simple. Then they come to land. Then, you know, if they get spliced with a certain particular animal, they'll have the ability to fly. Okay? So these sea spiders, these sea tarantulas, these sea scorpions, they're all directly related to the crabs, and they're directly related to the lobsters. Okay? So when you eat a shrimp, you're eating a sea roach. When you're eating a lobster or a crab, you're eating a sea spider, a sea tarantula, and a sea scorpion. Okay? Directly related to crabs and lobsters. Okay? Crustaceans are directly related to insects and arachnids. Plain and simple. Okay? Here goes a centipede. Here goes a centipede. Okay? I did my research. I do not believe a centipede was spliced with any other creature. Centipedes are very ancient, very old species that have been here for a very, very long time, ladies and gentlemen. Okay? Same thing with the millipede. Same thing with the millipede. This right here is a dragon millipede that is able to shoot a toxic gas out of these spikes, okay, and basically poison any creature trying to harm it. Okay? This creature, centipede and millipede, come from the ocean. Come from the ocean, okay? This is a sea centipede. The centipede species and the millipede species comes directly from the ocean, ladies and gentlemen. Okay, straight from the sea centipede. As above, so below, we all start out in the water. All life forms once lived in the water. Okay, I'm going to be touching on that information in a later lecture. My next video is going to be touching on more genetic splicing as far as animals that we consider mammals, but are really aquatic. They're aquatic mammals, okay? I'm going to be touching on that in the next lecture. So that basically sums up all I had to say on this topic. I appreciate everyone who supports RFG movement and Atlantean movement. Like, subscribe, share this video. It's the chosen one, man.